Hello, everyone. It's a pleasure to be here today. My name is Reem Khojah, and I'm really super excited to present my first Beak talk. As I just told Christine that I never missed a Beak meeting once I learned that about this wonderful initiative led by Professor Christine King, along with Professor Alexis Ortiz Rosario. And I really found that Beak leadership is always thinking outside the box and making resources available and really convenient to access for a new teaching faculty like me. So as I began to hone in my craft in teaching, I really found everything I need and to jumpstart my career in one place, which is the Beak virtual website. So thank you for maintaining Beak Society, and thank you again for inviting me here today. So to start, um, we all know that students spend 25% of their academic life in lectures, and that has a profound impact in their academic journey. From the faculty perspective, this 1 hour, 1 hour and 20 minutes lecture may seem like a small part of the educational process, but it's actually the effectiveness and efficiency of a lecture, what learning outcome to include in a lecture are just one aspect of really its broader impact. So, which extends to multiple levels by the course itself, the program, department, institution to accomplish this educational goals for students. So before I start about the main topic today, I would just like to take a step back and share my personal story and experience when I first started teaching and preparing lectures at UCSD. So I prepared my course and worked on the course learning outcomes based on Bloom's taxonomy. And for that, I would really like to thank the Active Learning Institute at UCI and their 8-week course that I took during my postdoc. Like, wow, Bloom's taxonomy, all this good stuff. And I know that it's I just want to give them a huge shout out to this amazing program. And I know this lecture might be, attended by students or postdocs in the future. So I just wanted to include the resources and links directly into the slides. And also I'd like to highlight another course that I took during my postdoc at the Center of the Integration of Research, Teaching and Learning, CERTO program, which have been founded by the University of Wisconsin-Madison, of course, renowned by their exceptional focus in teaching and education. So I did everything by the book. I prepared my lecture to hit certain learning goals in the course, certain learning outcomes, but no one had ever prepared me for the students' reaction when I tried to get their feedback during the lecture, just to gauge their understanding on class. So I tried to read their facial expression, and I found that there are two types of students. The first type, students have a great poker face and exude this confidence, but their grades told a different story. And then the second type, they were always nervous with blank stares, and they say they will fail the class, and then they get the highest grades. And I remember that I was collecting a midterm in one of the classes, and the students refused to give me their midterm papers because they said they will fail the class. And after we played a little tug of war with their midterm papers, I graded the midterm, and they got the highest grades in class. So this got me really extremely frustrated and confused as I applied everything I learned by the book, but I could not gauge, if me and the students are in the same page. And that really stressed me out. And I found that they were like this dynamic variable that changes every single lecture, like a lecture dependent variable. So that really bothered me as an engineer first, and as a teacher as well. So, and as you know, like we can stop several times during class and ask questions to check with the students' understanding, but we cannot do that regularly for two reasons. Well, one, it's not scalable for large classes. So I teach an introductory class with more than 100 students, so that's not going to work. And so there's large population, but small sample number. The second reason is that some students don't do well under pressure. So sometimes I will be collecting bad and reliable data. So I couldn't get anything measurable to gauge the student understanding during the lecture before moving to the next topic. It cannot be measured, can't be managed. So I really wished as an engineer to have something measurable, like scalable, maybe like, this graph where it can represent, students' understanding in this plot, and also the student perceives readiness to this class. So we always hope that the students would be in the upper right corner. And so, right. So this is, of course, particularly challenging because that changes every lecture. And not only that, it's more even challenging because in teaching bioengineering, and which requires an interdisciplinary cumulative learning process. So where mastering some concepts is crucial before progressing to the next lecture. And biomedical engineering education is very unique than other engineering fields, in which it's the only one where we, introduce a new system of partial differential equations. And in the next lecture, we cover stress and strain and their influence, mechanical behavior in biomaterials. And in the next lecture, we examine how those mechanics influence cellular expression and genomic activity. So I really have to make sure that the students are in the same page with me, the same page before moving to the next lecture. And this made me quite nervous because I could, and also I didn't want to wait until the end of the course to get feedback. And more importantly, I really want to hone in my craft in teaching based on data. So my desire to find a real-time student feedback had led to the study. It's a very simple idea. You test the students before the lecture, and after the lecture, same questions. So I get 2 data points. The first data point from the pre-lecture test results is used as a baseline for the student's understanding. And it allows me to normalize the second data point, which is the post-lecture test result. And this will get a quantifiable measure of the student learning right after the lecture or right after intervention. So, and to gauge how well the student grasped the concepts in the lecture, we used Bloom's taxonomy to structure the assessment questions. So I immediately took this idea to Dr. Doyle from the Teaching and Learning Commons at UCSD. And we found a lot of publications with this method across various disciplines, but there was a significant gap in applying the pre and post in research in bioengineering. So this is how my collaboration with Dr. Doyle began. And we thought about applying this method in bioengineering since, the cumulative learning process is really desperately needed in this field. So we conducted a pilot studies on undergraduate students, primarily freshmen with a diverse background and in a programming course. And we decided to focus on testing. There's just the first 3 levels of Bloom's taxonomy: remember, understand, and application. So to design the pre and post lecture questions, we consider it from the student perspective to ensure that we have a strong buy-in and balance it with the goals of the study. So after all, students, dislike change, and even more so, they don't like take quizzes and questions. So our first goal was to collect as much data as possible, and that means that we have to have a high class participation. So we decided that the test should not be intimidating. We made it low stakes, and also the results of the test will not, show students' names. So I mention every time the students are taking the pre and post test that this is a mini test, will not contribute whatsoever to the final grade. And only you will get participation points from this class discussion. Our second goal was we wanted to be frequent without the students getting, survey fatigue. So we kept it sweet and short, mainly MCQ questions, and we used Pull Everywhere so it's really accessible for the students. The third goal was we want to have a meaningful and measurable results. So we don't want students to randomly, pick answers. So we added an additional option, I don't know, plus a positive message with this, I don't know, but I will learn this in the lecture for the pre-lecture test, or in the post-lecture test, I don't know, but I'll find out after class with a relatable cool emoji. So every time I remind the students that is normal if you don't know the answer before class, And it's good to tell me that you don't know the answer after class. This way I can review the section together and clear up any confusions. And also you can go home with a solid grasp of all the concepts in the lecture. And also if it's something that you don't understand, then it'll save you time in studying so you can study more effectively. So now this is how the results look like. So on the left, you see the pre-lecture test, and on the right, you'll see the post-lecture test. And you can see that the student did not shy away from choosing the I don't know option. And this by itself adjusts the student readiness perception. So our last goal was we want to share and display the results for the students. So we want to give them accessible feedback. So after class, we go over the questions and we go over why this is the correct answer. And the results were anonymous, so the students felt safe and more comfortable participating, even if they don't know the answer. And the students also can adjust their perception of readiness and can study more effectively after class. So as an instructor, also I can get a sense of the class understanding and identify which concepts that need to be repeated, for example. In this case, I needed to repeat explaining some concepts because half of the students did not get the right answer after class. So at the end of the course, we did a paired t-test to compare pre and post-lecture scores for each student. And as we move up the Bloom's taxonomy levels, the bigger the difference between the pre and post test results. And next, we wanted to see if this method can predict low-performing students in class. So I correlated the pre and post results with other traditional assessment in class. And we got the most shocking results, but again, it is expected with the presence of Gen AI. The pre and post class test had a higher correlation to the student's performance than homeworks. And actually, homeworks got actually negatively correlated to the student performance in classes C in blue, negative side. And I really want to talk more about this point at the end. I know it's a lengthy discussion, but we can just continue just showing the results of this particular study, and then we have a discussion at the end. So at the end of the course, we collected student survey as well, and we found that the student received it very well. We got a really strong student buy-in and execution. Like nearly all the students found the pre and post-lecture assessment accessible, engaging, and they really liked that it was anonymous, and they found that it was a good use of class time. And also, I was curious to know if this, from the student's perspective, if this method improved my teaching and learning in class. And I found that the students were, found that this highlighted the core concepts in class, helped me assess my understanding, and also the instructor improved the class. So I was really happy about that I could do that continuously and dynamically. So, and a pre-post improved my understanding as well. So I was really happy about that results. Okay, so now let's take it from the instructor perspective. The main concern with any instructor, with any active learning activity in class is its time constraint and its predictability. So, but this activity only took 10 minutes. So 5 minutes before class, 5 minutes after class, and it really got built up with the student routine. So once the student entered the class, I just find them opening, the pre-lecture test because I have the link near the lecture title. So it's really got built in. So the students, before they leave, just, open the phones even without telling them to take the post-lecture test. And if I don't post the lecture results in Canvas, they actually seek me out. Like, where's the, can you just share the test results? So students like that. And again, this really helped me as an instructor to adjust my lecture in real time. So the pre-lecture or the pre-test gave me real-time feedback of which concept that I need to emphasize in class. Remember that, as I mentioned the lecture before, or the slides before that, we have a diverse background of students. So it's really helped me to get an understanding or gauge an understanding of where the students are coming from. And also, the post-lecture test enabled me to address student questions and clear any confusions on the spot. So that means less emails after the class. And I was able to follow up with students at that were challenged by the course and provide early intervention. And in this, one of the comments from the students actually mentioned and repeatedly mentions in the evaluations that about the pre and post lecture quizzes. And this is one of my favorite comments. The pre and post lecture quizzes helped me know how I was doing with the subject, if I needed to put more effort, or if I had to keep in line with the topic that was introduced today. So that also gives the student, feedback, and the students really want to have continuous feedback. So that made the students happy as well. Okay, so now let's talk the disadvantages from the instructor perspective. I really had to put extra hours to, first to prepare their questions, and also to de-identify students to get an RRB exception, and also extra hours to do, the grade and do the statistical results, extra hours just to share the results anonymously with the students, as Pull Everywhere. If some of you used it before, you have to just, remove a lot of data, and there's so much process that happens just to give that. And I realized how this is valued by the students, and I really want to continue doing that, but I can't if it's, happening this way. So when I was preparing these slides in June before my ASEE presentation, I thought of a very simple way to eliminate all these pain points for the instructor. And I made a small website demo before my presentation in ASEE. Do you want to try it? Anyone want to try the demo?
I will.
Yeah.
All right. Awesome.
You posted
Cool.
a chat.
So let us, I can actually go through, you can actually get the QR code here. What we will do is that we are going to, you can go to prepostclass.com demo/demo, or you can just, grab your phone and get the QR code. You are going to get a pre-test, and then I'm going to give you just a tiny small lecture, and then you're going to get a post-test. So you can try it yourself. All right. So if you are taking the pre-test, once you finish the 3 MCQ questions, you just can keep your page open until I give this small tiny lecture, and then we can go to the post-test.
It has, I don't know. Things I
Oh
don't
yeah,
know.
yeah. This does not have that option, unfortunately, in the demo. Okay, so when you reach the thank you page, you can put your phone down without closing the page, and then I'll give a small, tiny, fun lecture. Okay, so I'll give a small, very small lecture about the science of behind making a sourdough bread. So how many of you tried, to make a sourdough bread during COVID? I think, well, I tried, but I didn't get it right. So let's talk about the fascinating science behind making the perfect sourdough bread. So it all starts with just the simple ingredients like water and flour, transformed to this wonderful loaf of bread. So let's explore how this happens. So first, let's start with the sourdough starter. And it's just a mixture of water and flour, but the simple mixture capture wild yeast from environment, and lactic acid bacteria also from the environment. So these microorganisms play a key role in making this perfect sourdough bread. So let's start with the wild yeast. So these yeasts break down the starch in the flour into simple sugar like maltose or glucose using enzymes like amylase. And then these sugar are then fermented by the wild yeast, producing mainly, carbon dioxide and also ethanol. But ethanol gets evaporated during cooking. So the carbon dioxide is the main byproduct by this fermentation process, and it creates bubbles in the dough, causing the bread to rise, this lovely texture that we all love. And meanwhile, let's talk now about the second section, which is the lactic acid bacteria. It converts the same sugars into lactic acid, which gives the bread its sour flavor. And then this lactic acid builds up, and it lowers the pH of the dough, creating an acidic environment. And this acidic environment helps break down the gluten, in which the protein in the dough, into smaller peptides. And this makes the bread easier to digest. All right, so now you know the amazing science behind making a perfect sourdough bread, and you can do that at home. Now you can go to the post-test and see if you can, get all the answers right after this small lecture. Okay, so let us now check the results together. I'm actually going to go to the site. So, basically you can submit your answers for the pre, as we did before, and then you wait for the lecture, and then you'll submit the answers for the post. And so what you get at the end is actually a live feedback and update of how many students answered it correctly, how many students are answered it wrong or correctly, and then you get the right answer. It's a very simple code, very simple website demo. So at the end, you'll get direct feedback of how did you do before class and how did you after class. And I hope like a lot of you got, the answers correctly after class. So this is just a small demo of the website. Now I am going to make it, accessible for all, teaching faculty to do their own questions. And this is just the answer to these questions. Of course, we're going to go through them after, class, which is, I mentioned, it's lactic acid bacteria. So you should pick Lactobacillus amphisis. And then also we mentioned that the main byproduct of the fermentation is carbon dioxide, because ethanol gets evaporated afterwards. And then of course the correct answer is that if you want, which of the following method can help speed up the sourdough baking process without affecting its digestibility? So you want to decrease the water, increase the amount of starter dough, and decrease the pH, of course, and then increase the temperature. So do you see now we went on and to the 3 first Bloom's taxonomy levels: the knowing, the comprehension, and the application. So in this, and some of the comments that I got from ASEE is generating questions. Every lecture takes time. So now in the new site, I'm making. So I'm making another. Actually, this I'm going to build it in through the website. Oops, sorry. So I have to. It's a very simple code, and I used OpenAI API to do that. So you can drop your lecture file in PDF, and then it can generate the questions for you, the MCQ questions. Oops. Oh,
It'd be a plain text file?
A PDF. So I think because I uploaded it again. Let's see. Yeah, usually
I get my lecture transcripts in Word. So
right.
I just print them as a PDF.
Yes. So you can print them as a PDF and then do that. So let me actually just try to upload a file in, and it then generates the question for you instead of
So you upload a PowerPoint, or you upload like you said, a transcript?
a PDF of transcript of, yeah.
A PDF of the transcript, though.
Yes.
Can you do like a PDF of a PowerPoint?
Yes. So I just uploaded a PDF of a PowerPoint.
PowerPoint. Okay. Or a transcript. Okay.
Let's see.
That's awesome.
Yeah. So let's see if I
And
can
it will generate questions.
do that. Of course, demo does not work. So let me.
Yeah, it's engineering.
Try.
Never works on demo day.
Yeah, exactly. So I'll try another lecture and then see how it goes.
But this is also on the prepostclass.com website?
I just have this in a Linux server to test it
Okay.
out. So
You're developing it. That's your website, prepostclass.com?
yes.
Okay.
So for some reason it's not working, but I can send you the demo later on. So actually,
Yeah, no
if I
problem.
go back maybe a couple of trials, I might be able to, oops, to get it. Well, anyways, I can send it to you later
Yeah.
and then see
So
how
I
it
know
goes.
in the and I'll put your website in the link right here. I saw when you log in, like you give everyone like enter your email, and so you'll be getting emails of people interested, I guess, in using the site.
You got mine
Right.
already.
Yeah.
Yeah, that's
Oh,
what I was saying. Because this was the first thing I did. I was like, oh, cool.
yeah. So definitely, if you have, I'll have your email in the database and do that for
Perfect.
you. I can just record maybe a video how this works for generating questions, and you can maybe stitch it in the video. I'm sure. But anyways, it actually generates the MCQ questions for you. And then you can, upload it. So you don't have to make MCQ questions every time in every lecture. So you just upload your lecture PDF, and then it generates the MCQ questions for you based on different Bloom's taxonomy level, all the 6 levels. So this is how I coded the OpenAI API. All right, so the next one was data analysis and student feedback. And with this one, I got really lucky because in one of the CAMSI meetings, so CAMSI is BEAK meetings, but it's at UCSD, it's campus-wide, and it's the Center of Advancing Multidisciplinary Scholarship for Excellence in Education. So they were a small family at UCSD and it connected me to a lot of teaching faculty from different departments to learn new teaching approaches, and we share ideas with our colleagues. And it's really cool about these meetings. They give you 30 minutes to socialize before the talk, so we got a lot of exchange ideas and learn about each other's work. So with that, I really like to thank CAMSI leadership in making this wonderful space. In one of the talks, Professor Liam Mueller spoke about, from the biological science department, presented his work on analyzing results of the pre and post results of core courses. And this is a wonderful initiative from the biological science departments. Only the core courses, they do a pre-post course test. And luckily for me, he's a statistician, so he will help me analyze this data, hopefully to another level in which we can make sense of or the complexity of pre and post data, and just so we can identify who students needs more help in the course, how can we give them better feedback. So I'm really excited to start a collaboration with Professor Mueller with this project. And so let's see. Right. So next, just want to go back to one of the slides and discuss how can we design fair assessment as so many students use Gen AI in their homework, as this is really prevalent in one of the results of one of the courses that I got. And with that, I just want to refer one of the comments from the professor's page in Reddit, instructor called Publish and Perish, that recommends moving all assessments in the classroom. And I believe that the pre and post formative assessment do a very good job in this. I know this is a lengthy discussion, and I want to make more time to discuss with you at the end. So with that, at the end, I just want to summarize that pre-post were really well received from students. I see that in my student evaluation. They mention it many times. And I think this might be because they really want to get continuous feedback throughout the course. And I think also, I'm now working on a paper for ASEE next year. So stay tuned for more studies on a graduate course level, applying this in graduate course level. And here we apply all Bloom's taxonomy questions. And with the other, also current collaboration with Professor Mueller from the bioscience department, I would love also to get more sense of this data, also applying it in core classes, hopefully. So I like collaborating with people. Please Stay connected, and this is my email if you have any questions, and I'm really happy to hear your questions right now and discussions.